For today, we are going to open up our tutor marks save data file, and we are going to be doing a one-way repeated measures ANOVA with the Bonferroni follow-up test. And so to do that, we're going to open up our data, analyze. We're going to go to general linear model repeated measures. And then from here, I put in lecture because on the actual file it says lecture, but you can do tutor, and then it says levels 4, and then you'll go to define, and then all of these would be over here, and you would select all of them in order and put them over to our within variable. And then we can't do post hoc because of how our data is set up. And then we're going to do both of these display means, and we're going to compare mean effects, and we're going to hit our Bonferroni so we can run those tests. And then we're going to do estimate of effect sizes, observed power, continue, and OK. And that's going to pull up the same data that I have up here. So our multivariates test are Malkley's test of sphericity, and our pairwise comparisons are going to be what we're looking at mainly. So from our multivariate test, the only thing we're looking at is our Wilks lambda, and from here you can see that our significance is above 0.05. So the data was not significant, but from our from our sphericity test, you can see that our significance is below 0.05. So we can reject the null hypothesis because of this. It's basically just stating that one professor has a significant difference between the two. To make this easier, you can name these if you so please. Like, you can change this and make it say fields is the first one, and then the second one, and then scroll, and then death if you want to, which I actually did that up here. But this is the only one that is relevant to us. This should say Smith, and then you can see this significance is below 0.05, so we can tell that only 2 professors had a significant difference in how they marked, and everyone else is not significant, as you can see here. And then the mean difference between Field and Smith was 4.625. And then from there we can tell that since they are the only ones who have a significant difference, that overall none of the data was significant enough, which is why the multivariate test is above 0.05, because only one had significant differences in the marks, but it wasn't significant enough. And then it says to answer the questions that were on the packet. It says to answer, and then the 2 questions were what kind of analysis did we run, and that was going to be the repeated measures, which I walked us through, and then the other question was, do the findings support the hypothesis? And then the answer is no, because it said that someone graded harder than others, and so right here, since we don't have significance, we can reject that because there was no value that was significant enough.